So today we will see something about the mist system. Okay. I hope in the allied like software you don't have any problem and doing the hydraulic calculation. But still, if you want, we can do one more problem. But let us do that problem in the last, because uh, still you can do practice and then we can once again revise the software if you want it. Okay, so by that time you can also do the practice. Now let us see something about the mist system. Now the mist system is something what you can say a little bit different from the wet sprinkler system, because this wet sprinkler system, normally what we called it as the sprinkler system. So this sprinkler system is a very common system actually. If you check this, so normally in the common areas we go with the wet sprinkler system, but mist sprinkler system we don't go with the common spaces. Why means because this mist system is the mist system is created only to protect those areas which are what you can say which affect aesthetic. Okay, sometimes what happens if you are going in a five-star hotels, so in the five-star hotels what happens if you are going with the normal sprinkler system, so normally what happens whenever any fire occurs, so that particular wet sprinkler system damage the property and all. Okay, like some precious things will be there in five-star hotels, so that's why they prefer mostly mist system. But again, it depend upon the project to project, or it depend upon the client whether they are going with the mist system or not. Okay, this is one common. And second thing is that there are certain spaces which are preferable for mist system. Okay, there is one document, NFPA 750. In that NFPA 750, you will learn a lot about the mist system. Okay, there are certain spaces electrical room, generator room, turbine room. So these are the places which are mostly suitable for mist system. Wet sprinkler system is a very general system, like corridor areas or any offices, residential, in residential also bedrooms. Okay, so these are the spaces. So first let us see some difference between mist system and wet sprinkler system. Then we will go to the NFPA 750. Okay, so I will show you one video where you will understand the difference between wet sprinkler system and the mist sprinkler system. Okay, so let me just open that video and you will understand it. It's a very small video. See, this is the water mist system. So just just I hope you understood that the mist system is nothing but, here the most important thing what happens in mist system. Suppose, for example, this is one room, okay, and suppose the fire started in this place, for example. So what happens? This system, mist system, first what it will do. First, it will try to what you can say block the heat, whatever the heat which is coming out of this fire. So first, it is try to block, and it will try to limit that heat to particular confined space only. Okay, and after that, the mist system starts working. So normally, where mist system can be used, just now, like in that by that video, you have understood it. But in NFPA 750 also they have mentioned clearly what are the suitable places where we can go with the mist system. Now let us see the NFPA 750, and what does this NFPA 750 tells about the mist system. Let us go quickly, and let us try to understand. Remember that hydraulic calculation method remains same only. Whatever we have done, okay, just some pressure values and all will change. Otherwise, everything will remain same only. So let us see first what does this particular book is talking about the mist system. So first, initially you can just skip these things like definitions and all. So many things are given, so we don't require this definition. Okay, in different definitions you can just go through that. Some important definitions will be given, like about the mist system only. Like here they have given some single fluid system, twin fluid, water mist nozzle. Okay, some definitions are given, so you can go through that. Here also you can see that high pressure, intermediate, low pressure. Now this is the most important point. So here what happens, just understand that mist system works from pressure 175 psi up to 500 psi. The low pressure system is nothing but where the distribution piping is exposed to pressure of 175 psi. One is intermediate pressure, where the pressure is greater than 175 psi but less than 500 psi, and a high pressure is greater than 500 psi. So this one point is little bit important. Okay, and here some definitions are given, like twin fluid system, water mist, single fluid system. Okay, so that thing I think we will come across. Again, we will come across that. And here they have given types of water mist system. That means water mist system can be attached with deluge valve also. Just remember, whenever we are talking about the deluge, the meaning of deluge system is that all the sprinkler heads are open. So water mist system can be attached to the deluge system. It can also attach to the dry pipe. Okay, dry system also. Dry system means there will be one control valve which is controlling the system. In case of fire, then only the valve will open and the water is going to enter into that particular system. Okay, and engineered water mist system, something they have given local application, pre-action, even pre-action water mist system can be like used here. Wet pipe water mist system can be applied. This is the like general, like all the wet sprinkler system. This is how the wet pipe water mist system. Some things are given here. Okay. And here they have given water mist system shall be permitted for use with a wide range of including. Okay, some things are given. Okay, leave this. Classification is given here. Again, classification is the same whatever we have seen in NFPA 13, like light hazard, ordinary hazard group 1, ordinary hazard group 2. But this classification is little bit important. Specific application for water mist system, like machinery spaces, combustion turbine, wet benches, local application, industrial oil cookers, computer room raised floors, chemical fume hoods, continuous wood board presses. So we understood that this water mist system is used in the industrial. Mostly it is used in the industrial system, industrial buildings. If you want to use in the like commercial, then can go with the hotel or a 5-star hotels, 7-star hotels, or can go with the like any computer room, server rooms, because the meaning of water mist system is a spray of water. Okay, and after that some things are given here. Leave these things, like they have given some like gas water container, so it is not required. Piping and tubing, and here they have given something about low pressure system. Even this is not required, just they have given some clauses here. So we can just skip here and just skip these sections because these things are not okay. Here they have given the, again they have given the same thing, sprinkler classification color code. So I think this classification, this table is exactly similar what we have seen in NFPA 13. So this is also the same thing, and here they have given the glass bulb and fusible link. Okay, and this is the temperature classification. See, as a designer, we can never understand that just by seeing sprinkler, we cannot say whether it is a mist sprinkler, dry sprinkler, wet sprinkler. But as a manufacturer, they will know, okay, what is the type of sprinkler. Okay, if you want to buy mist sprinkler, the mist sprinkler will be like understood by manufacturer, but we cannot understand that. That is the thing. And something they have given like walls and all, strainers, filters. So you can just skip these things. Just they have given some definitions and all. Okay, our main focus is for the hydraulic calculation part. So which will be given somewhere here. System requirements, like what is the system requirement whenever you are using the mist system. Water mist system shall be described by the following 4 parameters: system application, nozzle type, system operation method, system media type. So again, they have given system applications. What are the type of system application? Occupancy, total compartment, local. Okay. Nozzle type means, like in nozzle type, again, they have given whether it should be automatic, non-automatic, multifunctional. And system operation method, what is the system requirement? They have given here. So obviously we know what is the system requirement. So system requirement is nothing but just a general. We have to protect that space by using sprinkler system. So whether you can go with deluge system, pre-action system, dry system, wet system, that will be the system requirement. The new thing is system media type. So let us see what they have given about the system media type. See, media system type is 1. The water mist system shall be classified by 2, single fluid, twin fluid. So single fluid and twin fluid, what is the meaning of single fluid and twin fluid? So just go a little bit up. Some definition was given here. See, a water mist system utilizing a single piping system to supply each nozzle is called as single fluid. A water mist system in which water and an atomizing medium are supplied to the water mist. Now here they have used one term called as atomizing medium. Maybe this atomizing medium is the one which is blocking the radiant heat. Okay, like in mist system, the heat will be blocked. So maybe because of this atomizing medium, the radiant heat will be blocked and it will be entrapped in that confined space. So that's why they have given here the atomizing medium. So, and obviously, most of the details you will get from the manufacturer when you are talking about this complete mist system set. After that, what they have given, let us see. Okay, this is the system requirements they have given. After that, okay, here they have given protection area also. You see, they have given the protection area, how much maximum area. So I think this is also exactly similar what is given in NFPA 13, like light hazard 4831 square meter, ordinary hazard 4831 square meter. So this is also the similar what we have seen in NFPA 13. Multiple buildings attached to canopies covered, okay, shall be permitted to be supplied by a single system riser. Okay, they have given something. Nozzle height limitation, at what height it should be installed. So here they have clearly mentioned, see this particular, the minimum maximum height shall be in accordance with the manufacturer's listing. So you need to go with the manufacturer, like what is the preferred height and what is the minimum maximum height. Even they have given the distance from wall also. The minimum maximum distance from nozzle to wall or partition shall be accordance with the manufacturer's listing. Distance below ceiling, obstruction to nozzle, everything they are telling that check with the manufacturer. Whenever you are selecting for mist system, just check the manufacturer and select according to that, as per this document I am telling you. Then thermally activated nozzle temperature ratings. Okay, they have given something about the sprinklers here. So you can just check these things. These things, temperature rating of nozzle based on, okay, these things are not required actually. Some things are given here. Hanger maximum spacing and all. Okay, spacings. is given. You can leave this. Walls and pressure gauges. Something about the walls and all is given here. And check wall, backflow preventer, pressure regulating valve. Again, here they have given the pressure regulating valve means, again you have to understand that where you are installing PRVs, if the pressure is going high, so there we have to install this pressure regulating valve. So obviously with the help of Elite software, you can easily design. You have to follow the same procedure, just you have to change the pressure values. Okay, based on that you have to design. And here they have given the locations where you can install the pressure gauges. Like that, some things are given. Electrical requirements is also given here. And design objectives, fire test protocols. Okay, these things are not required actually. So many things are given here. You can just go through that. This is also one of the important table. Here they have given the hose stream allowance and water supply duration for occupancy protection system. Light hazard hose stream allowance is 100 GPM. Ordinary hazard is 250 GPM. Hazard residential up to 4 stories not applicable. Residential 1 or 2 not applicable. It means that in the residential building we cannot use the mist system. Now what is this hose stream allowance? Again, this hose stream allowance is nothing but if we are using the hose system, then we have to follow this. But here they have not given anything about inside or outside. They have not given inside or outside hose, just they have given the hose stream allowance. So whenever we are using the hydrant system, we have to follow this particular GPM. Okay, 100 GPM and 250 GPM. And duration is also given here, 30 minute or 60 minute. That means for 30 minute, whatever the tank we are selecting, it should at least supply water for up to 30 minutes. By understanding, our understanding from this duration minutes is this only. Like for light hazard, you have to design a tank in such a way that it should supply water up to 30, at least for 30 minutes. Okay. And apart from that, here they have given just follow NFPA 14. Whenever you are having standpipe system, follow NFPA 14. So NFPA 14 is nothing but we have already seen NFPA 14. So that thing you can check. And apart from that, let us go towards the calculation or hydraulic calculation. See, this is the flow calculation procedure. System flow calculation procedure for water mist system shall be in accordance with one of the following. Hydraulic calculation shall be performed using the method provided in section 11.2. So maybe one section is given here. Hydraulic calculation for system with no additive work for not exceeding will be permitted to perform. Okay, some things are given here. So let us see what method they have given. If you go a little bit down here, you will see that one method they have given here, Darcy's Weisbach calculation method. So here they have given for the system whose pressure is greater than 12 bar or 175 psi. Here they are telling use follow this method, Darcy's Weisbach calculation, and here some formulas are given here. So this calculation even I don't know, but here they have given one thing. Hydraulic calculation shall be permitted to be performed using the Hazen-Williams calculation method for intermediate and high pressure having a minimum 20 mm pipe size, provided that the maximum flow velocity through the system piping does not exceed 25 feet per second. So this point is telling that you can also use Hazen-Williams. Once the Hazen-Williams comes means just understand that whatever we have seen in the manual calculation, or we can also perform Elite software also, because Elite software is also mostly based on the Hazen-Williams calculation only. So this point is telling that you can go with the Elite method also. Here what it is telling that the maximum flow velocity should be 25 feet per second. In our wet calculation, we have kept 23 feet per second. So here we will change this to 25 feet per second. This is one difference, the velocity, based on this particular point. Next, here they have given some Moody diagram and all. So even I don't know this method, what they have given, because this is the entirely different method. And here they have given the Hazen-Williams calculation for low pressure system. Low pressure system is the one whose pressure is 12 bar or 175 psi if you are talking about the mist system. And here they have given some tables. And here you will see that The same method will be given here. Hazen-Williams formula. Okay. And C factor. Okay. C factor is also given here. Equivalent length of pipe for copper fittings and valves. So here understand that here they are talking about the copper fitting. They are not using the GI or MS pipe. Instead of that, they are using the copper pipe, and here they have given the equivalent pipe length for copper fittings. And also they will be giving the C value here. C value for copper is 150. So just understand that we have to go with the copper system here. Copper pipe here. And there is no K factor is given here. We haven't find anything related with the K factor here. Only they have given the Hazen-Williams formula here, the one which we have used. Okay, K factor is not given here. C factor is given, but K factor is not given here. And here they have given some calculation procedure for propellant gas or atomizing media. So different methods are also given here. You can just leave this. Just understand that the same procedure what we have done in NFPA 13. Water supply and atomizing media. And here okay, here they have not given anything. Just they have given some clauses here, like how much water we have to keep reserve supply. Those things are given here. You can just skip this. Fire department connection shall not be required for the following: water mist system protecting less than 200 square meters. So minimum requirement for mist system is 2000 square feet. At least we require an area of 2000 square feet just by this point. System with design pressure in excess of 12 bar supplied only by storage cylinder. So if any system is only like you are using storage cylinder, so this system fire department connection shall not be required. System where the atomizing medium is essential for fire suppression. So this you need to we need to confirm with the manufacturer only. So where these things are applicable. Atomizing medium. Now here they are talking.
If area is less than 2000 square foot, then we can use another method, or we don't need to use anything.
I think if area is less than 2000 square feet, we don't need fire department connection. The system can be used, but fire department connection cannot be used, because here the fire department connection, once the fire department connection comes, just understand that we have to design hydrant system also and sprinkler system, because whenever fire department connections are coming, so they will be like going for hose connection only. So that is the thing. Apart from that, I will share you, like I will show you one more book. Okay, hydraulic calculation document. Okay, these things you can just skip this. System acceptance. So many things are given here, and let us see what is given, because I will show you one very good book. Okay, apart from this, okay, nothing is given here. Just they have given some diagrams and some structural calculations and all. Nozzle placement they have given, where to place nozzle and all. So yeah, I think this is also one of the schematic representation is given here. Suppose if you are going with the atomizing agent, how it is connected. Okay, mist system is the one. It will come with a it is a system actually. So maybe some control panel and all will come. So this diagram will take you to that particular, and here they have written high pressure system. And in the same way, this is also given one high pressure system schematic arrangement. But I will tell that if you go with the manufacturer, they will better what you can say explain us about the system. And this is also one of the twin fluid water mist system. They have given some drawing. Single fluid water mist system, control panel, and there are so many things are given here. So you can just go through that for your knowledge purpose. So many diagrams are given here. And apart from that, I think nothing is given here. There is one book actually. I will share this book with you. So this one book actually I downloaded from Johnson and Control. Here you can see they have given very beautifully about the mist system. First, they will talk about there. Now here they have given certain images you can see here. So might be this is the control system and this is the sprinkler. Water mist system, how do they work? So here they have given the definition also. The definition of water mist as per NFPA 750. It is defined as a water spray for which the 99% of flow weighted cumulative volumetric distribution is less than 1000 microns. So they have given certain definition in NFPA 715. They have highlighted the section also. So if you go to that NFPA 750, you will get the same definition. And here they have given some of their like brands like Aqua Mist, ULF, Aqua Mist, FCG, some sprinklers like this company, what they are making. How does it work? Three main effects: inerting, cooling, fuel wetting. Now here they have given how the mist system works. First, they have given the inerting. System displaces oxygen in the vicinity of fire. Water droplets vaporize and absorb heat. Maybe this is the place, second, where the radiant heat is absorbed here. Third, water droplets wet fuel sources preventing the fire from propagating. Some definition is given here according to this particular Johnson control document. Types of water mist system. How does the water mist system looks like? And some important points as per NFPA 750 they have given. High pressure, intermediate, low pressure. Twin fluid system. So these are the important definitions. NFPA 25 for the inspection testing. And they have given some NFPA 770. Okay, this is some different thing, not required. And here they have given some scenarios, how the high pressure can be and how the low pressure can be. Just one scenario they have given. Now they will talk about the application for water mist system. And in that they have classified some fuel types. This is the classification based on this company, Johnson Control. Class A, Class B, Class C, Class K. So these are the expected industries where we can use this water mist system. This is what it is trying to tell. And here you can see the applicable hazards also they have given. Type of buildings like combustible turbine, generator, hydraulic pump room, machinery spaces, chemical fume, data center, hospital, hotels, office building, residential building classified as light hazard for NFPA 13. Not applicable for NFPA 13R or 13D residential system. Some classification has been given here. Then they will talk about the different like low pressure water mist sprinkler system, or simply they have developed one Aqua Mist ULF. Operating pressure less than 500 psi, commercially available, or less than 300, low to intermediate. Typically, okay, many components are taken from conventional water spray. Some things are given here. And here they have given some, what are the pressure ranges available, and what it use, how, which water it is using, those things. And some, what you can say, technical orientations and all of the sprinkler is given here. K factor and all, approval. Okay, these things are given here. And they have also given where it can be used. Okay, next, light hazard. In light hazard, which are the rooms where we can use? This is given here. And some documents they have given light hazard. And the maximum water mist zone, minimum water supply duration. So many things are given. Even they have done some calculation also. I will show you. Light hazard application FM insured. See here. Here they have done one calculation also. Like how to find, okay, the spacing is also given, ceiling height is also given. So these are the like spacing, what is the maximum distance from wall, everything is given here. The calculation also they have done. Just you have to take one sprinkler and you have to do the calculation. Otherwise, like as per NFPA 750 is telling that you have to follow the manufacturer listing. So just pick one manufacturing company and you can get all the documents, related document. Only what we have to do means we can do only hydraulic calculation using Allied software. So what we can calculate using Allied software, what is the pressure, what is the flow. Rest everything we have to follow this system manufacturer only. And after that they have given some different hazard applications. Okay, these things even okay, so you can just leave this. Some image also given how this water mist system looks like. Some calculations they have given, different types of sprinkler and different what is the maximum spacing, minimum, those things are given. You can go through that, you will understand it very easily. Okay, next they have given for the machinery spaces and combustion turbine enclosure. So what are the acceptable hazards? So here they have given the broad classification like oil pumps, oil tanks, fuel filter, diesel engine, generator. Okay, generators, transformer valves, gearbox, drive shafts, etc., etc. And here also they have shown some example. Here they have shown some example for machinery space and combustion turbine. And what is the compartment volumes? Okay, they have given some volume and some things are given here. Calculation also they have done here. See, this is the calculation they have done. So you can follow that also. Cable tunnels, different rooms they have given. This book is very good actually. Sorry, this PDF here they have given about the data center application and data center application. So many things are given. I think you can see they have given also about the control center unit, how this unit, what are like their configuration and all they have given, and some pressure ranges also has been given. And I think this is the capacities are given. What is the working pressure, how much frequency, capacities, and what is the HP motor, everything is given here. So this thing is also, the schematic drawing is given. So these are the like these things are just we have to keep it for our what you can say knowledge purpose. If you are coming across any mist system, these are the very best documents for total compartments. Suppose if there is no power, then what you have to do, that procedure is given here. So these things you can just, there is one more document I think.
All.
There is one more document actually given. I think 1 minute. There is one more document actually. I'm just trying to find. I have kept one more document related to mist system. I think this one. See here, this is also very good document. Just they have given one example how to design the water mist system. So what is you have to do, that has been given here. Determine the hazard volume, determine the nozzle grid, determine the nozzle spacing, determine the size of micro mist system, determine the piping layout, determine the pipe sizing. Now to do this pipe sizing, we have to follow NFP13 only, hydraulic calculation. And rest you have to do the same calculation method like how we are doing, how we have done the calculation in manual method or the software method. So that thing can be done here. Only what you have to change is that here I have written that the procedure remains same, just working pressure shall not exceed. Okay, this is the low pressure system. In Allied software, what we have to do means we have to just change the maximum velocity to 25 feet per second, and rest everything remains same. And understand that whenever we are doing this, okay, whenever we are doing the Allied calculation, we have to go with the supply mode only here. Why means because in demand mode, we require the residual pressure. But here they have not mentioned anything about the residual pressure. Just remember this thing. They have not given anything about the residual pressure. Like in NFP13, they have given the residual pressure, okay, like 7 psi. But here in mist system, you have not, we don't find this residual pressure. So instead of going with demand mode, we can go with the supply mode, like where we can write any suitable pressure range from 175 psi to 500 psi, depend upon the type of the building and type of the pressure requirement. This thing, and next thing what we can do is we can change this value 25 feet per second. So these two changes you can do. Rest everything like pipe. If you want to select copper pipe, you can select the like number copper pipe, whatever the code number is given. C factor will automatically update it. K factor also you can select. Like K factor, how you can select means based on this document, they have given somewhere K factor. That value can be selected. Rest everything equivalent type, equivalent pipe length and all will automatically update. So rest everything remains same only. So just remember that whenever you are doing this mesh system, so where we have to follow this mesh system only in a certain places. Okay, like if you are if the client is asking you about the mesh system, then only you have to go with this particular mesh system. Otherwise, everywhere we are following the wet sprinkler system only. And I think this by this document you will clearly understand what is the difference between this mesh system and the wet sprinkler system. Okay, there are 3-4 documents. Just go through that. And any other question you want to ask? I have just shown you the overview here, so you can go through in a very like detail, because in detail it is given. So many things are given here about the different types of industry. So you need to go now. Firefighting is the one you have to actually determine which type of industry you are designing, and based on that you have to like search so many documents. Okay, so this is about the mesh system. If you want to ask any question related to this particular, any question if you want to ask, you can ask. Apart from that,
Mr. Atif, are you going to have an example for FM200 calculation or water foam system and the blader tanks?
yes, see FM200. Okay, we will see this FM200 also. It's very simple actually. Normally in gas separation system, what is required? Now this particular will come in gas separation system. You take
But in the mist,
yeah, gas separation system. So yeah, mesh system is like you don't have to do the calculation. Just you have to do the calculation whatever we are doing in the Allied software. Okay, the same. Just what you have to change means you have to change the pipe to copper, and you have to change the pressure range to 175 psi, more than 175 psi. Okay, because the mesh system starts from this pressure. Our wet sprinkler system ends at this pressure 175 psi, and the mesh system starts from this pressure 175 to 500 psi. So this is the range given here. And the third thing what we have to change, where we have to give the velocity, the maximum velocity, we have to change it to 25 feet per second. This
for the oil transformers, I use water spray system. Is this mist system? Water spray system.
Water spray system is called as
mist. This is the mist.
Yeah.
Right. For the water foam with the blader tank, it is suppression.
Foam we will see. Foam we will see in our next class. We will see that in next class.
The water foam with the blader tank, which category? Mist or suppression?
That is a different system. Foam system only. That is NFPS 16 actually. That is different. Now in gas separation system, what we need to do means we have to calculate the gas capacity. First thing, and second thing, what we need to calculate, how many number of nozzles required.
Yes.
Example, 10 kg gas. I'm just giving you one example, 2 nozzles. Only these things you have to calculate. Rest everything will be taken care by the manufacturer.
We will take it in later stages. This calculation later we will take it.
It's very simple actually. FM200. It's like we can take now also, because I will show you. It's very simple calculation. There is one document. From that document only you can do the calculation. See, there is one like one company called as Minimax. So based Minimax, see here I have written the calculation steps also from Minimax only. What you have to do means simply you have to let us close this. First, what we have to do in FM200 calculation means, or anything, whether it is a Novec 1230 CO2, First, you need to identify the hazard. Now, this hazard is entirely different from the light, ordinary, or extra hazard. Okay, this hazard is different. Like here, the examples are given as acetone, electrical, propane, butane. So I will show you that also. Here you will see that there is one document here actually.
You will share us these documents, right?
Yeah, I will share you. See this document, you can see everything is given here only in this document. Here they have given the hazard to protect. Acetone, acetonitrile, benzene, butane, commercial heptane, crude oil, diesel, diethyl, ethanol, hydraulic oils, etc. Electrical, transformer oil. So these are certain areas where you can use FM200 system. So first step, what we need to do means we need to understand what is the material we are trying to protect, whether it is acetone, electrical, propane, butane. Once you identify this, second thing what you have to do means you have to get the design concentration factor. How to get the design concentration factor?
From the table, I think you just showed us.
Yes. Number is written here, 7.5 for electrical, for example.
This is concentration of the gas, right?
Yes, concentration of the gas. Once you get this design concentration, you have to get the flooding factor. For flooding factor, this is the formula given actually. W is equals to V by S into C by 100 minus C, or how to find S, K1 plus K2. I think this formula is not given here, or maybe it is given here. Let us see. See here, it is not given here, but it is given here actually. Now this document, this is also the same document. Okay, this is also the same document, but this is just one technical sheet, and this is the complete document. In this document, you will find that particular formula. What I have shown you, just I will show you that formula. Somewhere it is written here, the formula also. Where is that formula? See here, they have given that hazard to protect, design concentration. And if you go a little bit down, see here you will get the formula. W is equals to V by S into C by 100 minus C, where W is the weight of clean agent, V is the hazard volume, C is the design concentration, S is the specific volume. And here the specific volume is also given formula. So this is the third step. Once you get this thing, get the volume of the space, multiply step number 3 and 4, you will get the quantity of system. Now this particular document, okay, this particular what I have shown you sheet, here they have given the calculation. See here, this is also they have given. You can see this particular number. So here what they have done, they have already done this calculation by inputting this formula. They have done calculation here, like for different temperature ranges, like 30 degree Fahrenheit up to 130 degree Fahrenheit. They have done this just calculation. And this particular value, what they will do, they will multiply with the volume of the space. Suppose for example here, if you are going with 60 degree Fahrenheit and design concentration 8, you will get this value 0.0402. This 0.0402, they will multiply with the volume 64 cubic feet. So you will get 2.5 or 3 pound system. Like that, they will do this calculation. Very simple. And once you get this, get the system volume enclosure, get the nozzle sizing for the above system and nozzle area and coverage. For that also they have written here the maximum area coverage for one system. Suppose for example, I will show you this. It's very simple. Suppose if your building is like this is 10 feet, this is 20 feet, and the height is for example 10 feet. So first you need to get the volume. Volume will become equals to 10 into 10, 100, 100 into 20 is 2000, I think so. 2000 square feet. For example, cubic feet, sorry. This is the volume, 2000 cubic feet. Now, based on this volume, suppose this is my electrical room, for example. And for electrical room, what is the value given here? See, this is the electrical room, value is given as 7.5 design concentration. So once you get this 7.5, what you have to do? You have to come to this flooding factor. Now here 7.5 is not given, but 8 is given. And here the temperature is given.
In between.
In between.
Do you have to go for interpolation or
interpolation? No, you don't have to go for directly go for 8, the higher number.
Okay.
Just you should understand what is the temperature you are doing. For example, here he has given an example for 60 Fahrenheit. The value is 0.0402. So what I will do, just I will multiply with 0.0402. If I multiply with this, I will get certain value into 0.0402, 80.4. For example, I got 80.4 pound. This is my system requirement. Here you see 64 cubic feet multiplied with 0.042, they got 2.5. Now, one thing you have calculated. You have calculated the gas quantity. Okay, this is my gas quantity. Now, from Google also, you can convert it to kg also. Like what is the kg? You can check that. Second thing, what I have to do means I have to calculate how many nozzles are required. How to find nozzles? Here they have given one table. They have given 3 systems. 3 pound, 7 pound, 14 pound. Suppose if I am going with the 7 pound system, if I am going with the 7 pound system, so one 7 pound system can cover 129 square feet area. 129 square feet area. So how many cylinders are required? Next question arises that number of cylinders, because we require the number of cylinder also. To calculate number of cylinders, simply what I will do, I will divide 80.4 by 7, because our each what you can say, our each cylinder nozzle is what you can say capable of 7 pound. So I will divide 80.4 divided by 7. I am getting 11.4 cylinders, or simply what I can do, I can go with 12 nozzles. Okay, sorry, 12 cylinders, not nozzles. 12 cylinders. And how many nozzles we require? We have 200 square feet area. Okay, 200 square feet area. And one nozzle can cover 129 square feet. So just divide 200 by 129. So obviously we'll get 1 point something. So it's better to go with 2 nozzles. Simply what we have done here, we have calculated how many cylinders required, how many nozzles required, what is the gas quantity required. So these 3 things, what we need to do, we have to give to the vendor. Like what is the gas kg, what is the number of cylinder, what is the nozzle. They will also cross check and they will do the calculation. The same
for 2 nozzles we need 12 cylinders.
I am just showing you as per this particular example, like whatever the calculation they have shown according to this. Okay.
What will be the duration?
1 minute. 1 minute.
1 minute.
Area is, yeah, maximum area coverage is, yeah, this is the fine actually, because the area is like here I have taken, it should be 200 square.
What is this 200 feet square? Coverage area?
Fine. This is the coverage area. This
each cubic each nozzle? Each nozzle?
No, it's room area. No?
It's room volume actually. 2000 cubic feet is room volume.
Room volume.
Oh, boss, this is feet square. This is area, not volume.
This is square. See, first you have to calculate the volume. Why to calculate volume means to get the quantity of gas. How much gas is required for that particular. Now, here I have taken the general. Okay. Here I have just taken one general space. Like normally, I think you have to make some compartments also. Even though if you are going for a very bigger room, you have to go with compartment like thing. Here I have just taken one bigger room. Just I have taken, for example, just understand by this example. Here they have taken 4 feet by 2 feet by 8 feet. This is the room. Okay. For this small room, 8 square feet, they require 3 pound system. Okay, just one example I'm telling you. And there are different documents I will show you. Now here you see one calculator is also given here, FM200 gas fire extinguisher calculator. So with this method also, with this also you can do. Here what you have to do, just you have to write, for example, if I am giving the room area, 200 square feet means I will convert it into square meter divided by 10.76. So what will be it become 10.76. Suppose it is something around 19 square meter. Okay, so I will write the area is 19 square meter. Room height is 3.5 meter. 10 feet is 3.5 feet only, that is right. So what will be the volume? 0.5 cubic meter. And minimum anticipated temperature of the protected area. Suppose if you are changing any temperature here, like I am changing 20, certain values will change here. Okay, so how you can change this? Just you can cross check with this particular, and if you know exactly what is the temperature there, so you can change the temperature, and all the calculations will be done here automatically. It is given in kg, so you can convert it into pounds also. And here they have given the values. Everything is just you have to change these three values. What is the room area? What is the height? What is the volume? What is the temperature? This is one sheet. In the same way, here you will see one thing is given for gas flooding system. There is also, this is also one system. Here also you have to do the same thing, but procedure remains same only. Okay, calculation, leave this. I will show you one more. Here there is one like calculator is given here. So here also they have done the same thing. Like if I am going with the FM200, they have given two things: system nozzle, cylinder capacity. First, let us see the cylinder capacity. And here they have given a certain type of fuel and all. What is the type of, okay, not, they have not given any like only 4 to 5 classification is given here. So, and here some temperature ranges is given. So here what you have to do, just you have to write the volume and you will get the capacity, but it is limited actually. This is given limited for acetone and heptane, isopropane and surface fires. Only this thing is given. And if you are going with this FM200 system nozzle, so this is also given something. Suppose if I am going with 80, means here it is showing 0.4 number of nozzles, SI or branch. So it depends actually. This is already fitted. So there are different, but I think this particular document is the very best document, okay, for calculation, because everything is given here. Like what is the design concentration for different temperatures, and for 3-pound system, 7-pound system, 14-pound system, even they have given the design concentration also. Or otherwise, this particular book also, this book is also very good, and this Excel sheet is also just taken from that book only. All the formulas are fitted, just you have to change 3 values. And I think we have seen this video also. I will show you once again how this FM200 system works actually. It's a very small video. Just I will show you. See this one. Here you will see how the cylinders and everything are arranged. Just check this video. It will be 2-3 minutes.
It looks like the Novak.
Sorry?
It looks like Novak.
Yeah, every system remains same only. Novak FM200 CO2. Just the name changes. Actually, FM200 is a chemical. CO2 is a chemical. Novak 1230 is also a chemical. I think this Novak 1230 is now what you can say. It is changing. Like now, FM200 is the is the leading gas suppression system, because there are certain problems in Novak 1230. I think so, because of its properties. Like it is just like in HVAC we have two gases, no, like R22 gas It is a polluted, like it is a kind of polluted gas actually, that NOAT 1230. So FM200 is something which is, I think, environmental friendly. So they are going with this FM200. Otherwise, all the system remains same. We have to calculate only these two things. What is the capacity and what is the nozzle? Even though if you don't know how many cylinders are required, you can ask to the vendor, like, boss, this is my capacity, 20 pound system I require. You only suggest me how many cylinders are required. They will suggest it. Just say this. So this is something only what I think, like in FM200 system, normally what happens, whatever the system you are like utilizing that system. So whenever any fire occurs, so all the room, like suppose if you have any ventilation system or any windows, everything will be closed, because what they will do means they will restrict the fire. And mostly you will see in the server rooms, okay, like mostly the main server rooms, like the main, for example, uh, there is a company Microsoft, and there will be very big server rooms for that. So maybe in those places they are using this system, because this system will like damage, the damage is very little if they are going with this FM200 mist system. Okay, like every system has some speciality actually. Like sprinkler, wet sprinkler system is like very suitable for the common areas. And if you are going with the mist system, it is very suitable for the critical areas. If you are going with the foam system, so foam system, I think we can use in the areas where there is a chances of any chemical reaction with water, or any what you can say, because of this foam, sometimes what happens, like in the aircraft hangars and all. So this maybe this, because of this foam, the fire will be extinguished very fastly. So there are certain things. So every system has a speciality actually, and deluge system is nothing but it is a common system. You can combine deluge system with anything. Like you can combine with mist system, foam system, wet sprinkler system, dry sprinkler system. Because deluge system is the one where all the sprinkler heads are open, and wet sprinkler system is the one where only that particular sprinkler will be activated. Okay. So
Mr. Atif, what about
yeah,
the hydraulic calculation for FM200? There is hydraulic
FM,
calculation as
there
well.
is no hydraulic
And
calculation
if you
for
change,
FM
and if
200.
you no, there is hydraulic calculation, and if you change the size for any reason, they will redo the calculation from the for sure.
You have to only calculate the gas capacity. There is no hydraulic calculation for FM 200. Gas capacity and nozzle. Whatever the piping system and solenoid valves, pressure switches, that arrangement will be done by the vendor itself. Because whatever the companies like Minimax is there, or so many companies are there, like they will just ask two things only: what is the gas requirement, what is the nozzle requirement. Rest everything will be done by them only. They will, because they will have the standard set of installation procedure. And remember that this particular gas suppression system is installed individually. Suppose for example I have 10 rooms. Suppose I'm having 10 rooms. So what we have to do, for each and every room we have to install individual FM200 system. It is not like that one FM200 we are installing for all the room. It is not like that. For each and every room we have to go with the different set of systems. Suppose some room will get 3 cylinders, some room will get 2 cylinder, some room is very big, they will get 5 cylinder. Like that it will be installed only. And everything will be like vendor or the manufacturer, the one who is installing. So they will have the proper what you can say, the standard procedures. So they will follow that only. The pipe sizing.
And in standard, they will also tell you when in gas system, two cylinders are working or two standby
Yes,
or
yes,
one standby.
yes. That exactly. Those things will be given by the installation team only, like the one who are manufacturing. So there are certain things. Okay, because as a design engineer, now this is what I understood from this firefighting. As a design engineer, we need to know only these two three things, like what is the pressure I'm going to maintain in this building, what is the flow I require in the building, and sometimes if you are going with the gas, so what is the capacity. Okay, capacity will talk everything, like what is the flow, what is the pressure. And since you are doing the allied calculation, so you have an upper hand, you can also calculate the maximum velocity also. So design engineer is restricted to only these three things. Rest special cases will be there. So there you have to take a help of manufacturer only. Why means because as a designer you cannot take risk. Okay, like even though if you are going to design any fire system for tanks protection, so you have to take help of manufacturer, because we can only decide what is the pressure, what is the capacity, what is the velocity I'm going to maintain. Rest everything, like by seeing the, like by coordinating with the manufacturer only, we are going to get most of the things. Okay. And I will also show you one document where they have discussed about the special equipments. There are so many special equipments in firefighting. So this special equipment we will take one separate class also. And in that special equipment, the like the manufacturer has already decided what will be the maximum flow, what will be the pressure, what will be the range of that particular equipment, like how much throw, 50 meter, 100 meter, or circular, or it is rectangular, or it is horizontal, vertical. Everything is given in that. So that thing we will see separately. So for now, just understand that what is the difference between mist system and wet sprinkler system. In the same way, in our tomorrow's class, we will check about the foam system, like how foam system is different, mist system and wet sprinkler system. Yeah.
Mr. Atif, what is the working pressure of these cylinders and these FM200 nozzles? What is the working pressure?
I think I need to check this document for that. Maybe they have given everything about this. I will check it, and if I get any information, I will share that document with you. If I have any technical data, so I need to just check that, because the question what you have asked it, this is a completely manufacturer's question. Like, what is the pressure? What is that like temperature they are maintaining? What is the pressure of that knob?
No, but there is both the cylinders, the manifold cylinders of the FM200. It has certain pressure. It is pressurized already. The
Yes, yes, it
manifold
is a,
cylinders.
obviously it is a pressurized system only. I think
I do believe it is
checked that.
500 psi. I think it's 500. I do believe it's around 500 psi. I don't know, or something like that.
Maybe, but I think in this document they have given something about the pressure also. I just need to check. Here also one you can check, but I think it is given somewhere. I just need to check that. If I get anything, I will tell you. See, here also they have given cylinder temperature and pressure. Some pressures are given, but these are the confusing actually. So we should get some technical data. If I get some technical data, I will share it with you, because I think there is one more book. 1 minute. This is Novak 1230. See, this is also one of the calculation method for Novak 1230. This method is little bit
There
different.
should be pressure.
This is little bit different method. So we will discuss this tomorrow, because it's little bit confusing actually. For me also it is little bit confusing, because certain values we have to take from different table, and these are the standard tables they have kept here. So this calculation for the Novak 1230, here also they will calculate the same thing. What is the kg, what is the the capacity of gas. This thing only they will calculate here. And there are different tables are given here actually, key factor table and all. Some things are there. I will tomorrow I will tell you this, how we have to get this. Whatever the calculation we are doing in FM200, just we need to calculate two things here. What is the capacity, how many number of nozzles are required. Rest everything will be guided by the manufacturer. Even they will show us the testing and all also. Those things also we will get it. Okay. So anyhow, we will stop here only today. Tomorrow we will discuss about the foam system, because this foam system is also very big actually. There are two NFPA involved here, 11 and 16. So I think let us see whether we can complete this tomorrow or not, because some in detail about the foam system is given, and you will find that foam system hydraulic calculation is exactly similar as per NFPA 13, whatever the NFPA 13, because in that NFPA 16 itself they have clearly mentioned that follow NFPA 13 for all the hydraulic calculations. So the document I will show you. Yeah.
It is not only foam, it is water foam, because there is a blader tank.
Yeah. Because
right? Foam should be.
There are two actually, NFPA 11 and NFPA 16. Both are for the foam system. So we will try to first crack the NFPA code for foam. Then we will see certain different videos and all, some documents related with foam system. Okay. So okay then, we will stop here. Tomorrow we will meet.
Thank you. Inshallah.
Thank you.
Thank you.